right, let's run through this.
Oh, you for real?
Huh?
You said no. I thought you were.
Oh, I was going to go over homework. It's my story. All right. Oh, we're going to cover that. All right. So problem number 1, let's see. 1, 2, 3, and 4, all you're doing, even if it's an inequality, is you're plugging in the x and y value to both. So for the inequality to work, they have to be a true and a true. They both have to be true statements. So is anyone need to see 1, 2, 3, or 4? Which one you want to see? Number 2? Okay. So problem number 2, we have this, and we have this. And they give us this point to see if it works, right? So that's an x and y value. So you're going to plug it in. So if I plug my x value in here, I get 6 minus negative 6. So it's 6 minus negative 6. That's 6 plus 6. Is that 12? Yeah, so it works on the first one. So that's the solution there. Let's plug it into the second one. Plug 3 in for the, so I get 12 plus negative 4 equals 10. So that's 8 equals 10. That's not true. So is that where these lines cross?
No.
No. So not solution. Not solution. Not. 3 or 4? Can you see? Yeah. 3 or 4? Number 4? Yeah. Okay. Number 4, we have. Let me do a different color so. Y is less than 2x, and x plus y is greater than 3. We have the point 2 comma 3, which is an x and y value. So we want to see if that is part of the solution. It doesn't necessarily have to lie on the lines for an inequality. It has to lie into where the region's true. So I'm going to plug that in. So that's going to give me 3 is less than 2 times 2, which is 4. Is 3 less than 4?
Yeah.
Yep. So it's true on the first one. On the second one, do the same thing. I get 2 plus 3 is greater than 3, so it's 5 greater than 3.
Yeah.
So that's also true. So is this part of the solution? Yes, solution.
Yeah.
Okay, it doesn't lay on the line, but it's an inequality, so you're just finding a region. Remember when we graph an inequality on a graph, you shade one side or the other, right?
Oh,
You pick a test point, and it's like that, shade the whole region. Remember that's when I made fun of you guys on saying you're going to have the one kid who's going to, during the test, spend 20 minutes shading in the whole region. And then that's going to be the same kid who has the eraser that doesn't exist, and it's the metal, and he's going to across the page.
That's not you guys. It was me.
You guys know the
Me.
shading. That's okay.
For you, yeah.
Hey, anytime it's for me, it's fine. 5, 6, or 7. Anyone want? Does anyone want to see any of those?
6.
Number 6, you got it, bud.
Numero 5.
Okay, so number 6 first. Graph and Cartesian. There we go. All right. So problem number 6 is y equals negative 3x plus 8. And then I get y equals 1/2 x plus 1. Correct? Well, I'll graph this one in red. So it has a y-intercept of 8. You know what? I'm going to get rid of my numbers. And I'll say that we're counting by 2s now, okay? And then 2, 4, 6, 8. We'll just count by 2s so it'll work out. So this is going to have a y-intercept of 8 as my first. And then I'm going to go down 3. So that's down 2, 3, and right 1. So about there. Does everyone feel comfortable how I plotted that? Because I'm counting by 2s. So then I'm going to draw my line of best fit. Then we'll do this one black. So I have a y-intercept of 1. So y-intercept of 1 is in between because we're counting by 2s again. And then we're going to go up 1. So I'm going to go up 1 and over 2. So that appears that if I had drawn that correctly, it should be crossing at 2, 2, I think. Does that make sense? So that appears to be 2, 2, and because my graph is a little goofy, it doesn't look like it's fitting right there. How can I verify if 2, 2 is exactly correct?
Plug it in.
Yeah, plug it in. So this is an x and a y value. It just has to be the exact same values for both. So you're going to plug it in. So I'll plug it in here first. 2 equals negative 3 times 2 is negative 6 plus 8. Is negative 6 plus 8 2?
Yes.
Okay, so that works there. This one works. Plug it into the second one. I get 2 equals 1/2 times x. My x value is also going to be 2 plus 1. What's half of 2? 1. So 2 equals 1 plus 1. Is that true?
Yeah.
So did I graph this right?
Yes.
Perfect. Any other questions from that very front page, 1 through 7? We good? Can I flip it to the back side? Okay. 8 through 10. Any on 8 through 10?
Number 10.
10. Number 10. So we have tools. No, math. Shoot, sorry. Ooh, that might work. Math. Graph table. No, I'm not going to do that. I was thinking I could. This is number 10, you said?
Yeah.
X plus y equals 5, and y equals negative x plus 3. On this one, I think I can leave my numeric values in there. Would that make sense?
Mhm.
I believe the cover method is going to work for us here. So if I do the cover method, what's my x value equal to? 5. What's my y value equal to?
5.
It also happens to be 5. That's fine. And here's my first one. Second one, how am I going to graph that one?
3.
Y-intercept is 3, which is right there. And then what?
Down 1.
Down 1, right 1? Huh. What do you guys and girls think about this problem?
Parallel.
They are parallel lines. What is the solution then? No solution. Good. Okay, they're parallel lines. There's no solution. Any of the other graphs up through number 13? Any of the other graphs up through number 13?
Number 8.
8, you got it. Number 8 is y equals 3x minus 1 and 2x minus 3y equals 10. I think I can leave my numeric values in there, even though it's got 10 because we're going to use the cover method on it. It should work. So my first line, this one, crosses the y-axis at negative 1. And then it has a slope up 3, right 1. Is that okay so far on number 1? Or the first part? Then a blue line. I think the cover method is going to work. If I cover that, what's my x value got to be equal to? 5. Now it's a little tougher here. Negative 3y equals 10.
Negative 3.9999.
Negative 3.33, right? Negative 3.33. So that's somewhere down here. Agreed? That appears maybe if I drew it totally right, what do you think? What did you guys get for an intersection?
Negative.
What did you get? Negative 1 what? Negative 1, negative 4? That might be right.
I didn't check.
That appears it could be right. I don't know, but we should check it. So, bless you. So that's my x and y value. If we plug them in, I'm going to get negative 4 is equal to 3 times negative 1 minus 1. Negative 4 equals negative 3 minus 1. Is that true? So it works there. Plug it on the other one. My x and y values. So 2 times negative 1 is negative 2. Minus 3 times negative 4, which is going to be that. That's negative, negative is positive. Is negative 2 plus 12, 10. Yeah, so it works on both. So that is the solution. 1 comma negative 4. Negative 1 comma negative 4. Excuse me. Are there any others that you would like to see on the graphing? Yeah. 12? Okay. Man. One day I'll learn how to use this really good and I won't make these errors. For the most part. You haven't seen me in geometry though. Boy. Whew.
Is it really hard?
No. No, it's I use the compass, so we're doing.
Wow. You use compasses in geometry?
Yeah, we use this. So.
What's that? Oh.
So it allows you to swing arcs.
That's cool.
All right. So this one appears the cover method would work nicely on. So if I cover up my y value, x equals what? 4. If I cover up my x value, I get negative 4y equals 12, so negative 3. Good. There's your first line. Second line, that's set up in slope-intercept form, so positive 2. Then I'm going to go up 2, right 1.
Guess. Six comma five.
I'm thinking negative 5, comma negative 6, maybe?
Probably.
Maybe. I mean, it looks like it's heading there. And I just free-handed it, so we should check that. So
I
that's
think it's -4, -6.
What do you think it is?
-4, -6. I just went.
Let's try negative 5, negative 6, see if it works. And then we'll try the negative 4, negative 6. Okay, so if I plug those in, I get 3 times negative 5 is negative 15 minus 4 times, so that's negative what?
4 times negative 6 got -24.
Negative 24 equals 12. So negative 15 plus 24, well, that's 9 equals 12. So that's not going to work. What do you think it was?
-4, -6.
So Joe thinks it might be negative 4, negative 6 on his. So you had negative 4. So you had like here, right? That might work. So let's see. So that doesn't work with the other one. So let's try negative 4, negative 6. So 3 times negative 4 is negative 12, right? And negative 4 times negative 4, or negative 4 times negative 6 is positive 24. Hey, that looks like that's going to work. That gives us 12 equals 12. It works.
Awesome.
It
Good
works.
job, Joseph.
Yeah, baby. And then I got, on this one, I got negative 6 equals 2 times negative 4. That's negative 8 plus 2. Negative 8 plus 2 is negative 6.
Negative 6 is equal to 6.
Awesome.
Good
So
job,
negative
Joseph.
4, negative 6 is the answer. Good job, bub.
Mr. Strip.
Yeah.
So, for the test, do we need to find that exact solution, or?
On the test, it's going to come out like an exact answer like that. So if you were to say, oh, it's 2 comma 3, and my answer should be 2 comma 4, I mean, you have the answer you think it is, and if you don't get true and true, you goofed up.
So that means we have to get the exact right answer.
And you guys can use rulers on the test and stuff. I mean, we'll make it to where it's going to be able to cross. I doubt I'm going to give you, plot the point 3 1/3, comma 5 1/7. That.
So it's going to be pretty hard.
Yeah. We'll do the biz. Okay, and then 14, 15, and 16. I just wanted to run through real quick. 14, we have y equals 2x and y equals 2x minus 5. What can you tell me about the slope of both of these? 2 is the slope, so they have the same slope. So these are parallel to each other. They don't appear to be the same line because one of them has minus 5 and one doesn't, right? So slope has parallel slopes, so there is no solution. These will not cross each other. Does that make sense? Number 13, we have y equals negative x plus 4, so that gives me a slope of negative 1, agreed? And my other one, we have it like this, and they didn't want us to graph, so what I want to do is I want to make this, how would I bring this x over?
Minus x.
So I'll subtract the x from both sides.
They're the exact same line.
Yeah, look at that. It's the same exact line. So how many solutions?
Infinite.
So same line, infinite solutions. And then the last one, y equals negative 3x plus 1, and y equals 2x plus 7. What's the slope of the top line?
Negative 3.
Negative 3. What's the slope of the bottom one?
2.
2. Different slopes, right? They're going to cross. So how many solutions? One solution. Did it ask us to find it?
No.
No, it said, without graphing, decide whether each system has one solution, no solution, or infinite. Okay, one solution. So this would be one that we'd get an x comma y value for if we were to have graphed it. Does that make sense?
Yes.
Feel good?
Yeah.
All right. Let's do this. Review, if this is okay. I plan on doing like 1 page a day. I asked you to do it. I didn't mark it off. I'm assuming you did it. But part of the review is not reteaching, okay? Does everybody have the review packet?
Yes.
Okay. Anyone need one? Good. All right. So let's take a look. What I'll do is I'll go through them quickly. Ask any questions about that page only. Okay. And then what we'll do is for Monday, I'll ask you to do 9 through 17 over the weekend. As far as the review. So problem number 1, let's just make sure we know how to do this. It says evaluate the expression for the given value of the variable. So they give us this big old weird looking fraction, and then they tell us that h is equal to -1. So what do you feel I should do on this problem? Yeah. Yeah. So we're gonna plug in for h. We're gonna put -1 in wherever we have an h in the whole problem. So I have -3 times 3. I'm gonna put a dash there. -2 over 2 plus dash. So there was an h there. What am I going to put in?
1.
Not 1, -1. So that's a -1, and that's a -1. So let's do it on top. I'm going to get -3 times -3 minus 2 over 2 plus -1 is 1. Okay? What do those come together to be? Negative what? -5. And then -3 times -5 is 15. Do I need to keep it over 1? I can if I want, but what's the answer labeled as? 15, so it's letter A. The answer to this is A. Okay? Anything about that type of problem that you need a little more clarification for? Good? All right, problem number 2. We have k over 24. So that's a division problem. How do you undo division? Multiply. So multiply each side by 24. So k is equal to 264. Right?
Yeah.
Which is D. I was like, whoa. Which is letter D. Okay? Everyone feel good about that one? And we're starting this review far enough in advance that we should have enough time to cover about everything. Okay? There'll be, starting like Thursday, Friday next week, we'll cover a little bit more of these at a time. But we'll be good. Number 3, -23 plus k is equal to -36. So I'm going to add 23 to both sides. Good. So k is equal to -13, which is B. Number 4, we have -7 is equal to x over 14. What am I going to do?
Multiply by 14.
Yeah, multiply each side times 14. X equals -98. Is that right? Which is B. Did I do that right? Sweet. Number 5. I have 5 plus 5 quantity 4 minus 4n equals -95. All right, so we want to start undoing this problem. So I'm going to distribute here and here. So that gives me 5 plus 20 minus 20n equals -95. Does everyone feel comfortable with that? Going to combine any like terms, so those need to be combined. So we get to that. Then what? Subtract 25 from each side. What does that come out to?
120.
Negative 120. Now how do we undo that?
Divide.
Divide by 20.
Divide each side by negative 20. So negative over negative is positive, right?
N equals 10.
Positive 6. Is that answer there?
Yep.
D? Cool. Number 6.
Wait, how's it?
Go ahead.
Number 5D. Wait, never mind. I'm looking at number 6. Never mind.
Okay. Here. You what? Over here? Number 6. Negative 74 equals 2 times 6x minus 1. So let's distribute here. Is that all right so far? Add 2 to both sides. Those cancel, so I get negative 72 is equal to 12x. Divide each side by 12. So x equals what? Negative 6. So that is B. Is that right? We're good? Number 7. We get 4 plus 4k plus 4 equals 10 plus 1 minus 4k minus 3. Okay, we have a whole bunch of like terms. So I'm going to combine those together real quick. So I get 4k plus 8. And then I have here, here, and here. That gives me 11 minus 3, which is 8. Is that right? Okay. Looks like if I subtract 8 from both sides, now I'm going to get 4k is equal to negative 4k. What does that mean? Oh, hang on. I'm just going to add 4k to both sides. 0. What is 4k added to 4k? 8k. So if I get 8k equals 0, divide each side by 8. What's 0 divided by 8? 0. My answer is 0.
Wait, why are you adding 4? Don't you subtract 4k? Since 4k on the left is positive. So 4k on the left.
This is the one I was moving, right? This is the one I'm moving.
Oh. I thought you were
7. So the answer number 7 looks like answer D. Yeah, watch your. That's one of those you got to watch your signs on it. Okay, get a little goofy. And then number 8. Number 8, we have 12 minus 6b equals 6 minus 4b. All right, so I might choose to add 6b to both sides. You might have chosen something different, but the answer will still be the same. So I get 12 is equal to 6 plus 2b minus 6 from both sides. Those cancel. So I get 6 equals 2b. Divide by 2. B equals 3, which is answer C. Cool. How do you feel?
Good.
Okay, do you see where your errors were? Okay. Do what?
Can we do the next page?
Yeah, I will cover that. So, your assignment tonight is page 155. It's only one side. It's exactly what we did last night, okay? So you're plugging in values, you're graphing them. So it's only 13 problems. And then what I would like you to do for Monday on the review is let's have you do, so this is from the review. Let's have you do 9 through 17. Numbers 9 through 17. So page 155, which is 13 problems, and then 9 through 17 on the review, and we'll do mimic Monday. And then we have a small lecture on Monday as well, but we'll have time to do all that. Sound good? I'm giving you guys, it's almost 20 minutes. I want to give you the opportunity to get things going because I know that it's a busy time of year. So make sure you're either working on this or this, okay? And I'm going to start saving the video.